Today I will take a look inside of this power outlet cover that has a built-in nightlight. I removed this from a power outlet installed in this house in a previous video, and I removed it because the lights were very dim even when the room was completely dark. There is some yellowing visible around each of the LEDs, making me wonder if they overheated. It has these 3 LEDs on the bottom and a light sensor on the front, and would fit around an ordinary duplex power outlet. And it would fit with these clips on the side, like this. Looks like a normal outlet. These side clips with some metal terminals will contact the screw terminals on the outlet to transfer power to the light. But this form of contact might not be the most reliable, but it does seem it's putting quite a bit of pressure on those terminals, so it should work with this only using half a watt. I'll put this out of the way. On the back there's some text, NA001, some numbers. This looks like a date code, might have been made in 2016, and is rated for 120 volts, 60 hertz, at half a watt. But now, I'll try to take this thing apart. It is held together by plastic rivets. There we go. Now we can start to see the wire coming from this terminal. And we can see a circuit board a little bit. There we go. This plastic cover that isolates the electronics has now been removed. I'll also remove this. This just comes out with very little force. This must have been installed for quite a while. I'll cut the wires. And the circuit board just comes out. Let's take a look at the circuit board up close. The power comes in through these 2 wires. They connect to points on the board labeled AC1 and AC2. Power goes through some resistors. This resistor has a crack on it, so that's likely the defective part making it not work. Seems to go through a couple resistors and capacitors, some transistors, the light sensor, and 3 LEDs. The LEDs on the circuit board are special side-emitting right-angle LEDs. They're using these to try and shine the light downwards through the ports on the faceplate. Interestingly, the light sensor on the board is marked LED4, but it isn't an LED. It instead seems to be some kind of phototransistor or photodiode, because it wouldn't make sense to be an LED if it is detecting if there is light or not. Another interesting thing about this is the lack of any UL or ETL certification on this, making me think that this was some cheap Amazon or eBay something. On the back side of the circuit board, there are some traces and vias for connecting various components together. What's interesting is that this is a 2-layer PCB, and usually in cheap mains-powered products they use single-layer PCBs. But I'll try to make a schematic of the board. I made a schematic of this little circuit, and it is kind of interesting. One important thing of note: this resistor, marked 271 on the board, supposed to be a 270 ohm resistor, has a crack in it, so it measures as an open circuit on my multimeter. This resistor matches with a small burn mark on the case, so that resistor failed open circuit as a fuse. But back to the schematic. The AC power comes in at terminals on each side of the board, marked AC1 and AC2. The AC1 terminal goes into a double diode marked KAE on the board, which has its part number. One side of that diode produces the positive of the internal power supply, going through the 3 LEDs in series. These are the 3 white LEDs, and then goes to another double diode, and then goes through a capacitor and a 470K resistor to drain it, the 270 ohm resistor that I measured as an open circuit, and a final 22 ohm resistor before going to the AC2 terminal. This capacitor, this small one here, measured as short circuit on my multimeter, so we could not measure its capacitance. This capacitor shorting is likely what made the whole system stop working and the 270 ohm resistor blow as a fuse. There's another side of the double diodes creating the negative lead, creating a bridge rectifier configuration so that the LEDs get both half cycles of the AC sine wave, so the LEDs do not flicker as much. Then, powered also from the LED circuit, is a photodiode, might be a phototransistor, but it's the light sensor on the board, and a 100K resistor. The midpoint between the resistor and the light sensor connects to the gate of an N-channel MOSFET. The drain of it connects to the positive lead of the LEDs, and the source connects to the negative terminal of all the LEDs. When there is light, this conducts, pulling the gate of the MOSFET to around the supply voltage, which makes the MOSFET conduct, shorting out the LEDs. Then, when there is no light, this acts as an open circuit. This 100K resistor pulls the gate down to the negative side of the LEDs, making the MOSFET stop conducting, so the LEDs will light up. This light sensor circuit shuts off the LEDs by shorting them, which probably is not the best for energy efficiency, as these resistors will be dissipating more power and AC current will still be flowing through the capacitor. Interestingly, there is no capacitor across the LEDs to reduce flicker, probably because it isn't needed at this nightlight intensity. These pads here are configured in such a way that capacitors could be installed across the LEDs to reduce flicker, but they were not installed in this version. To demonstrate the light sensor, I have my multimeter on resistance mode. It's currently showing around 800 ohms with the current ambient lighting. And then if I cover the light sensor, its resistance increases dramatically. Let's put this on the 2 megohm range. If I cover this, resistance goes up. It's definitely not linear. It's changing its resistance with the range, so it's definitely acting like a diode. But what matters is it conducts less when the room is dark, so that way, when the room is dark, the MOSFET can then turn off, allowing the LEDs to light up, and when the room is bright, this conducts more, pulling the MOSFET gate to the positive supply, shorting out the LEDs. To show that the capacitor also really is shorted, I will measure across the capacitor with my continuity test, and it beeps, so this tiny capacitor failed short. For curiosity's sake, I'm going to measure the size of this small ceramic capacitor. 1.2 by 2 millimeters. So 1220 metric size. Now, as this tiny capacitor is short-circuited, I am curious what happens if I put a bunch of current through it. Will it just blow open? I soldered these white wires to each side of the capacitor through these traces, and I have my power supply set to 2 volts DC at 50 milliamps. I'll turn on the output, and as you can see, it current limits straight away and goes to 40 millivolts. I will raise the current limit slowly. 100 milliamps, the capacitor is still shorted. 200 milliamps. It's passing 300 milliamps. 400 milliamps. Still holding. Oh. The voltage significantly increased when I went to 500 milliamps. 600 milliamps. 1 volt. So 0.6 of a watt going into that capacitor. And climbing. And it went open circuit. And capacitor got warm. Now let's see if we can measure its capacitance. Now my multimeter is set to the capacitance range. Let's keep these wires open circuit and measure our capacitor. 212 nanofarads. So I'll assume it's a 220 nanofarad capacitor. What's interesting is how applying current through it fixed the capacitor or blew the short clear. So I will look for a 220 nanofarad capacitor in this small form factor online and see what maximum voltage rating I can find. I checked electronic component supplier Mouser Electronics to see what maximum voltage rating capacitor I could find for 0805 package and 220 nanofarad capacitance, and the maximum voltage rating I found was only 100 volts. I also checked DigiKey for the same parameters, and once again the maximum voltage rating capacitor I found was only 100 volts. I even checked Chinese electronic component supplier LCSC for a capacitor of the same size and capacitance, and still The maximum capacitor voltage rating for this size and capacitance is 100 volts. This means that the nightlight circuit is clearly overvolting the capacitor a considerable amount, knowing the peaks of a 120 volt AC RMS sine wave are about 170 volts. In this 0805 form factor, if they wanted a capacitor that's properly rated to handle this voltage, a voltage rating of 250 volts provides a good margin, and at this rating, only 100 nanofarad or 0.1 microfarad capacitors are available in 0805 package. But anyways, this is what is inside of an LED nightlight wall plate for a power outlet. The circuit is designed in a little bit of an interesting way, and unfortunately, the failing of a small capacitor on it led to it shorting out and the resistor popping as a fuse. But anyways, make sure to subscribe for more videos.